Welcome to my video Building a Chatbot with Rasa NLU and Rasa Core. My name is Yuste, and this video is going to be a tutorial/project of how to create a fully functioning chatbot using two very powerful open source machine learning libraries for conversational AI, which together are called Rasa Stack. I believe that this video is going to be beginner friendly because I'm going to show you how to build a chatbot completely from scratch. For the purpose of this video, I decided to build quite simple but really fun real-time weather reporting chatbot, and this is a simplified architecture of how it's going to look like. So I will ask questions about the weather. For example, what's the weather like in London? And my bot will pick those messages and will crunch them using Rasa NLU model, which will perform entity extraction and intent classification tasks. Then, a dialog management model, which I will train using Rasa Core, will predict what action or response my chatbot should make at the specific state of the conversation. When I will ask for weather conditions, my chatbot will make an API call to retrieve real-time weather data and will use those details to create and send a response message back to me. I structured this video into 4 main parts, which will cover setup and installation, training of NLU model, training of dialog management model, and last but not least, chatbot integration to Slack. So follow along and let's build some chatbots. Let's start by setting up our working directory and installing necessary Python libraries. I have a folder called WeatherBot, and I'm going to use it as my project folder throughout this tutorial. Here I have a requirements.txt file, which I will use to install all necessary libraries and dependencies. I'm going to use Python 3.6 for this tutorial, but other versions should also work just fine. I'm going to open my terminal and go to WeatherBot directory, and I will do a simple pip installation to install the dependencies. And I'm going to do this by simply typing pip install -r requirements.txt, and this will install all libraries and dependencies in bulk, and this process should take roughly about a few minutes because we are installing quite a few dependencies here. I will give you a sneak peek into requirements.txt file so that we can see what we are installing. So we are going to have quite a few Rasa NLU dependencies installed, and since we are going to use language models as well as sklearn backend, we will need these libraries as well. And then we have a list of Rasa Core dependencies, and last but not least, some additional libraries. So for example, Slack client is going to be used to integrate our bot to Slack, and we will use API XU library, which will help us to make API calls and retrieve real-time weather data. So yeah, it's quite a long list of dependencies, but having in mind that we are installing two big libraries, it's not that bad. And it's always better to have all dependencies installed so that everything would work fine. So once installation is done, I'm going to install language model, and to do so I will have to open my terminal as administrator because sometimes it throws an error if you don't do this. So I'm going to type python -m spacey download n, and this is going to download English spacey model, and it will install it and append this to an abbreviation. And the language model is going to be used to parse incoming text messages and extract necessary information. And as long as my chatbot is going to be English-speaking chatbot, I'm using English model. So installation was successful, linking was successful, and I didn't get any errors, so it's all great, and I can move on to installing the last bit, which is Rasa NLU Trainer. And Rasa NLU Trainer is a really cool UI which makes generating training data for NLU models a lot easier. And this is a JavaScript-based application, and that's why we will need npm and Node.js installed. I'm going to get them from npmjs.com website, and I'm going to get them all together, which is really cool. And I'm going to get a version 8.9.4. And this is just a very simple installation. So I'm going to open up an installer, and I will keep everything default. I'm not going to make any changes in parameters, so nothing fancy. And now when the installation is done, npm will be added to my path, and that's why I will have to open a fresh terminal. And here I will type npm space I space dash G space Rasa dash NLU dash trainer. And this will install Rasa NLU trainer, which we are going to use in a few seconds when we will generate training data for our NLU models. It makes it a lot easier to create new examples and to do data annotation. So it's really handy tool to have. And yeah, we can see that it was installed correctly and we didn't get any errors, which is great. And now we can go ahead and train our first model. First, we should teach our chatbot how to understand unstructured human language so that our bot would understand what we are saying. For this, we will train an NLU model which will take unstructured text messages and will return structured data in the form of intents and entities, which our bot will be able to understand. Intents describe what the message is about, while the entities are the bits of information, for example, location names, dates, organization names, etc., which helps the chatbot to understand what specifically we are talking about or asking. Since entity extraction and intent classification tasks are machine learning problems, we will need some training data to train the models. Rasa NLU data should consist of example messages which we would like our chatbot to learn from, alongside the corresponding intents, as well as what entities are included in each sentence and where in a sentence they can be found. For this video, I am going to teach my weather bot to understand three types of intentions: greeting, saying goodbye, and asking for information about the weather. So let's see how we can generate some data for it. I'm back to my terminal, and in my weatherbot directory I will create a new folder called data, where I will keep all data files. In this data folder I will create an empty JSON file called data, and in this file I will add training examples for our NLU model. So you can see now in my project directory I have data folder and there is data.json file inside this folder. Now there are two different ways of how we can create training examples for an NLU model, and one of them is to write them directly into this data file, and this is what I'm going to do now. Okay, so I am in my data.json file, and let's get rid of this NLU data message to begin with. And we will keep JSON format, so let's add empty brackets, and now I'm going to set the name for my data, which will be Rasa NLU data. The key bit of NLU training data is called common examples, so I'll create this section here, so common examples. And common examples are going to be those messages that I would like my chatbot to learn from, and those examples should contain intents, entities, and the messages themselves. So as I have mentioned previously, I would like my chatbot to understand how I am greeting. So I will add one example down here. So new example. And I have to tell first of all what is the text input. And let's say I will provide a message hello. Now I have to tell what intent this message hello corresponds to. And since I am saying hello, intent is going to be greet. And lastly, I have to tell what entities I would like my chatbot to extract from this input message. So I'll specify entities. And since I don't have any entities that I want to be extracted, I will keep this empty. So this is how a simple training example looks like. Let's add another one. I would also like my chatbot to understand me saying goodbye. So I'll add another text example, and this time it will be goodbye. Let's tell what intent this message corresponds to. And this time intent will be goodbye. And again, what entities I have in this message. And since I don't have any, it is going to be empty. So you can add new examples to this file directly if you want to, keep adding them. But I find it quite tedious, and I would like to show you another way of generating data with Rasa NLU Trainer. So I will save this file, and I will go to my terminal, and being in my data folder, I will launch Rasa NLU Trainer by typing Rasa-NLU-trainer. And after pressing enter, I have this nice UI opened, and this is a data JSON file in a really nice UI. And you can see we have those examples that we added previously. So hello and goodbye with corresponding intents. And now let's add another example. I will click add new example. And in text tab, I will add new message. And this time it will be related to weather. So for example, I will write, what's the weather in Berlin at the moment? Now I have to tell what intent this message corresponds to. And since this message is a question about the weather, I will have to assign a completely new intent to this type of example. And I'm going to assign inform intent here. I also have entity in my text, Berlin, and it will be good for my chatbot to extract this entity and keep track of it. So I will simply highlight Berlin word, and by doing so, I'm going to create an annotation of where in a sentence this entity Berlin is. So I will click add an entity for Berlin. And the last thing is I have to assign a name to this entity. So since Berlin is location, I will create location name to this entity. And I will click add. And you can see this example was added to training examples. I will click save for now. And I will open my JSON file for a second. So I will reload this, and you can see our example was added here. And I just wanted to show you how entities look like in a JSON file. So I have entities bit, and you can see I have start and end values, which show where in a sentence our entity Berlin is, as well as value Berlin and entity name location. Well, it's obvious that 3 examples for training is not going to be enough. And if we want our chatbots to understand when we are greeting, when we're saying goodbye, and when we're asking things about the weather, we will need way more examples for each of these intents. And if we want our chatbot to be scalable, these examples should be diverse and different. So I have a little cheat here, and I have a data file made, which is on my GitHub. And what I'm going to do is I'm going to copy some of the examples and add to my data JSON file, and you can do the same. So I took the examples which I have on my GitHub page and added to this data.json file, and the file that I used from GitHub is called exactly the same, data.json. So I only added few additional examples of greeting, as well as saying goodbye and asking things about the weather. So I will reload NLU Trainer now to show you how that looks like in NLU Trainer UI. And this is how it looks like. So as I said, I have a few additional ways of greeting, as well as about 6 or so examples of saying goodbye. And I added few additional examples of questions about the weather. And you can see that I have examples of asking about weather conditions with entities included in those sentences, as well as some examples which don't have any entities. So yeah, in total I still have roughly about 40 examples or so, which is still considered quite a small data sample, but since my chatbot is going to be very simple, it will be enough to get started and to build a simple NLU model. So let's go and do that. So the first thing that we have to do before we actually train our NLU model is we have to create a configuration file. And I'm going to create a configuration file in my main project directory. So I'm going to simply leave this data folder. And here I will create a new empty JSON file, which I will call config spacey.json. And this is going to be the file where I will specify configuration parameters and use in training. So I can see that I have my configuration file created, so I'm going to open it. Okay, so let's delete this config. And configuration file is going to be important for model training because it will provide quite a few important parameters that are going to be used. And the first one is going to be pipeline. Now, pipeline is going to specify what featureizers, what feature extractors are going to be used to crunch text messages and extract necessary bits of information. And Rasa NLU has two main pipelines pre-built. One is MIDI based, the other one is sklearn based. And here I'm going to use sklearn based. So I'm going to provide a parameter spacey underscore sklearn. Now the second parameter is going to be path. And path means the directory where we will keep our model after it is trained. So for our example, I'm going to save my model in a directory called models and subfolder NLU. And the third parameter is called data. And this is basically where our training data is. And if you remember, we have it in data folder. It was called data.json. Okay, so these are the three main parameters that I'm going to pass to our model, and I will save this file because I'm going to use it in a few seconds. And now let's create our script for training the model. So I will create a new file. It's going to be Python file, and I will call it NLU model.py. And after it's created, I'm going to open it up. And yeah, I'm going to get rid of this NLU model. And this is where I will write the script for model training, basically. So first I'm going to import necessary libraries. So first one is from Rasa NLU, converters. I will import load data. Then I will also need from config, I will import Rasa NLU config, which will be used to load configuration files. And then from Rasa NLU models, I will also import trainer, which will do training for me. And now I will create a function which will be used to do all the training stuff. So I will call it train NLU, and it will need three main parameters. So the first one is data, our data file. The second one is a configuration file, which we just created. And the third one is going to be a directory where I'm going to save my model after it's trained. So the first thing that I'm going to do is I'm going to load the training data. I will create training data variable, and I will call load data function and pass data file. And then I will initialize a trainer. And there is a class trainer in Rasa NLU, which will do the training for me. And I have to provide a configuration file here, which I'm going to load using Rasa NLU config method, and I will pass my configuration file as a parameter, which is going to be called config. And once it's done, I can call my trainer's method train, and I will provide training data file. And this is where the training is going to happen. And the last thing is I have to initialize my model directory. So I'm going to do that, and I will call my trainer and its method persist, and I will provide as a parameter the directory where I would like to keep my train model, which is going to be provided as model dir parameter. And also I will set a fixed name for my model so that it would be easier to find, because otherwise Rasa NLU will assign unique name to that model. So I will call it weather NLU. And that's basically it. Now I can create main. And I'm just going to simply call train NLU function and provide the parameters. So the first one is data, so where our data file is. If you remember, it is in data folder and it was called data.json. Second parameter is configuration file, the one we just created, and it is called config underscore spacey.json. And the last one is where we will keep our model once it's trained, and I will save it in models folder and NLU subfolder. And now I'm going to save this script, and once I'm going to run it, our model should be trained. So I will run the script. I will call python NLU model.py. And after I hit enter, my model should be trained, so it shouldn't take long because we have really small data file, and indeed we can see that the process finished and my model was trained. And to be sure that I actually have my model trained, I can check the directory which I specified, which I would like to see my model in, and we can see there is a folder models in my project directory, and NLU subfolder, default subfolder, and weather NLU, which is my model. So all these files, they are going to make my NLU model, which I am going to test right now. And so I'm going to load my model and actually see how it performs on different text messages that I would like to test my model on. So I'm going to edit the same NLU model file and add some new stuff there. So the first thing that I'm going to do is I will load one additional library from Rasa NLU model. I will import metadata and interpreter. And both of these classes are going to be used to load my model and to get ready to use it. And below my train NLU function, I will create new function called run NLU. It's because it's going to be used to run the model and test it. I will not provide any parameters. And now I'm going to load my model. So I'm going to initialize a variable called interpreter, and I will call Rasa NLU's class interpreter and its method load, which will load my model. And that's why I have to specify the path of my pre-trained model. So it is in models, NLU, default, and weather NLU directory. And the second parameter which is needed here is my configuration file. I'm going to load it with Rasa NLU config, and I will provide my configuration file, which was called config underscore spacey.json. Great. So I will have my model loaded, and now I can actually try it out. So I will print the response that I will get from the model, and I will call my interpreter and its method parse. And in the brackets, I can now provide a message, question, or any text input that I would like to test my model on. So let me think. I will probably use something like, I am planning my holiday to Barcelona. I wonder what is the weather out there. Yeah, so this is a text message that I'm going to test my model on, and we will see how it will perform entity extraction and intent classification on this input. I'm sure I don't have this type of example in my training data, and now I'm going to simply comment out train NLU function, and I will call run NLU instead. So we don't need to retrain our model because it is already trained, so that's why train NLU is going to be commented out. So I'm going to save this file, and I will get back to my terminal now. And I will rerun my script, so the same python NLU model.py, and I should see some results, which is really exciting. And this is the output of Rasa NLU model. As you can see, it is quite a lot of information. And the first thing that we see is the results of intent classification. So basically we can see what the model thinks this input message was about. And we can see that the intent that I got is inform, and I have a confidence level for this intent. It is almost 79%. So basically the model thinks that my input message about me planning my holidays to Barcelona and asking about the weather conditions is weather related stuff. And it also found entity Barcelona, and it assigned the name to this entity, location. So actually it is really good because that's how it should have been, and both tasks were performed correctly. And we also see that there are some more interesting results. So Rasa NLU also provides intent classification results for all other intents that we had in our training data. So for example, my model also thought that with roughly about 10% confidence level, my input message was me saying goodbye, and another 10% confidence with me saying hello. So this is our model, and it actually performs pretty well. And now we can use those results in a few minutes when we will build our dialogue management model, and we will put all the pieces together into our chatbot. So let's move along to the next stage of the chatbot, which is dialogue management model. With a dialogue management model, we will implement the second half of our bot's architecture, so we are halfway through. As I have mentioned at the beginning of the video, a dialogue management model will predict what action or response my chatbot should make based on the state of the conversation. Those actions can be simple text responses or API calls or retrieving data from the database, etc. You might think, why do we need a machine learning model for that? Well, let me explain you using my WeatherBot example. This is how I would like my chatbot to behave in an idealistic world. When I will greet my bot, I would expect that my chatbot will be polite and will respond with a somewhat hello message as well. When I will say goodbye, I will want my chatbot to respond with goodbye message. When I will ask for the details about the weather, but I will not mention what location I am at or what location I am asking about, I will want my chatbot to ask me where I am based so that I would provide location details, and my bot would know what country or city it should retrieve real-time weather details for. And lastly, when I will ask for the weather details for a specific location, for example Paris, I will want my chatbot to make a response with weather details straight away. Quite often, in practice, these types of conversations are hard-coded in a form of flowcharts. Code-wise, you can imagine a bunch of if-else statements that if a user said this, then a bot has to respond with this specific response message, which means that a developer has to create a bunch of most possible happy paths of how a user can go from starting a conversation to the end goal, wherever this end goal is. Since my bot is very simple, it wouldn't be too difficult to do the same. But just imagine what would happen if I would add a bunch of new functions to my bot, even if I would just add one additional function of forecast reporting. If I would do this, I would add some new intents and entities to my NLU data, and with every new intent and entity that I add, I would add one another branch to my flowchart, which means that the difficulty of my bot's flowchart would grow exponentially, and it would be very difficult to monitor all possible paths which users could make to get to the answers they want. Rasa's algorithmic approach doesn't need any flowcharts. Instead, we can train a machine learning model which will make a prediction of what the bot should do next based on the context and the state of the conversation. As a result, a chatbot can keep a lot more natural conversation flow, which ensures way better user experience, and there is no need for hard-coded conversation rules, and it is a lot easier to monitor and improve such applications. Okay, so this was my motivation for Rasa Core dialogue management models. Now let's go and build one ourselves. So the first thing that we have to do now is to create a domain file for our chatbot. A domain is going to be a new file which I will create in my working weatherbot directory. So I will do this first, and then I will explain a little bit more of what domain is and what things we will have to provide in this file. So I will call my domain weather_domain, and it is going to be a YAML file, so that's why I have this .iml extension at the end of the file. And okay, I have my file created, and I'm going to open it up and edit the details that has to be provided in domain file. A domain is like a universe where a chatbot lives and operates, and of course it has to be familiar with its own environment, and that's why we need a domain, because the domain describes that environment. And the domain consists of 5 key parts. So let's initialize them here. So the first one is going to be a list of slots that our chatbot has to keep the track of. Then we have intents, entities, a list of templates, and a list of actions. So all of these details are important because they are going to be used in dialogue management model to make predictions. And Rasa Core dialogue management model makes predictions of what action should be executed next on the slots that are currently populated, on intents and entities that are returned by Rasa NLU model, so basically what a user spoke about, and also what actions were performed previously, so basically what is the state of the conversation at the moment. So now let's go ahead and fill all these pieces in. So I'm going to start with slots. Slots are like placeholders for the values that should help my chatbot to keep track of the context of the conversation. So for example, in my case, I'm going to ask questions about the weather conditions in specific locations. That's why it's going to make a perfect sense for my chatbot to keep track of the location that I'm asking about, so that I will not need to remind my chatbot what location I was speaking about initially if I will have some additional questions about the same location. And also, my chatbot will need to make an API call for that location that I'm asking about, so keeping the track of it is going to make it a lot easier for my chatbot to know what API call it should make at that specific moment. So I'm going to create a slot called location. And now what I have to do is to tell what data type the slot is going to have. It is important because different data types of the slots are going to have different effect on how dialogue management model is going to make predictions. So some data types are going to have an influence on predictions in a way that the value of the slot is going to be important. But for some data types, only whether or not the slot is populated is going to have impact on how prediction is being made. So in my case, as long as location is going to be text, I will provide type text for this slot. And that's it. I'm going to have only one slot for this example, but you can add more if you want to. The next thing that I'm going to add is a list of intents. And these are the same intents that we had in our NLU model. So I'm just going to provide the same ones. If you remember, we had 3 of them. So the first one was greet. The second was goodbye. And the third one was inform. And that's it. The next thing is a list of entities that my chatbot should be aware of and to be ready to get from the users. So we had only one entity, which was location. An important bit here is that since we have an entity called location and we have a slot called location as well, what's going to happen is, for example, when I will ask my chatbot what is the weather in Oslo at the moment, my NLU model will extract Oslo as an entity and will set this value as a slot because we have a slot called the same way, and that's how this value is going to be saved and kept throughout the conversation and can be used when needed. Moving on to the next bit, which is templates. So templates are like text responses that my chatbot should send back to the user once specific actions are being predicted. So let me give an example. When I will say hello to my chatbot, hopefully my dialogue management model will predict that a chatbot should send hello message back to a user. And here I can write down what message a chatbot should send me back once this send hello message back to a user action is predicted. So I'm going to initialize an action which should be executed when my dialogue management model will predict that a chatbot should respond with greeting message. So I'm going to initialize utterance greet. And now I can type the message which should be sent once this action is triggered. So I will write, hello, how can I help? Next, I will initialize an action for a message goodbye. So it will be utterance goodbye. And I will provide a message which this time will be talk to you later. Now, if you would like to add a little bit more diversity in what messages are being sent out once specific actions are predicted, you can provide more than one possible answer. So I'm going to add one more possible message that my chatbot will send once goodbye is triggered. So I'll say bye-bye and a sad face. And then basically my chatbot will randomize a little bit which answer it is going to use. And I will add a third action here. So for the case when I will ask for weather conditions but won't say what location I am at, so it will be utterance ask location. And I will add message which will be in what location. And the last bit is a list of actions that my chatbot should be ready to execute when they are predicted. So we already have 3 of them created in templates part, so I'm just going to simply write them down here. So the first one is utterance greet. Then I have utterance goodbye. The last one is utterance ask location. And that's it. But I actually haven't mentioned one more action which should be included here. And it is an action where my chatbot will respond with weather condition details. And I didn't include this action into templates part because this action is going to be a little bit more complicated than just a simple text response. because when I will ask about weather conditions in specific location, my chatbot will have to make an API call to retrieve those details and use them to create a response message. And for this action, we will create a custom action, and we will do this in a Python file. So now let's save this domain file and let's go and create our custom action. I'm going to create a custom action in a completely new Python script. So I'm back to my terminal and I'm going to create a file called actions.py. Okay, I'm going to open up the file and write the script here. So at first I'm going to load few functions from future module. And what future does, it simply enables new language features which are not or may not be compatible with current interpreter. So it's used for sanity of the code so that things would work with older versions of Python as well. And now I'm going to load few things from Rasa core package. So from Rasa core actions.action, I will import class action. And from Rasa core events, I will import slot set. Okay, so now I'm going to write the main class for this custom action. So I will initialize class, let's call it action weather, and I will pass Rasa core action. And inside this class, I will initialize the first function, which will be called name and self as parameter. And this function is not going to do much. We are just going to create the name of how this action should be triggered by the chatbot itself. So it's going to only return the name of the action, which I will call action underscore weather. So basically, whenever this action is going to be predicted, the chatbot will run everything that is in this class. And now I will create new function, run. And in this function, I will have few parameters. So the first one, self. Second one will be dispatcher. Third one will be tracker. And the last one is domain. Okay, so in this function, all the action will happen. And the first thing that we will have to do is to get ready for API calls, because this is where we'll retrieve the data. So we have a library for this, API XU, and I'm going to import this function. So from API XU client, I will import API XU client. And now I should provide API key. And this is where I have to provide the API key that I can get from API XU website. And I'll show you where you can get one as well. So this is API XU website, and API XU is a free of charge API which can provide real-time weather details, and I have logged in here, and if you want to, you can log in as well, and all you have to get is your API key. So I'm going to copy mine, and I will provide API key here. And now we should do authentication. So I will create client, and I will call API XU client, and I will provide my API key here. So basically it's just going to authenticate me as a user, and that I actually have an access to API XU data, and that it's me who is making this API call using Python script. And now, once I have my authenticated client, I can get ready to make API calls, but what I have to know is what location I should make an API call, because it wouldn't make any sense to make API calls for every country in the world. And as you remember, we have a slot which should keep track of locations that are mentioned by users throughout the conversation. So I will create a variable called loc, and I will call tracker and its method getSlot. And in the brackets, I will tell the name of the slot that I want to get the value from. So it is going to be location in our case. And now when we have location, which is going to be saved in this loc variable, we can make an API call for this location. So I will call it current, and let's call our client and its method get current weather. And as Q, I will provide the location name, which is saved in this loc variable. And when we will make an API call in this current variable, we will have a response data. Now, the response of this API call is going to be a dictionary. So I'm going to show you how it looks like. So this is how the response looks like. As you can see, it is quite a big dictionary, which has a lot of details provided, starting with conditions, so like what condition is in the specific area. Like here we have London example. So for example, is it sunny, is it rainy, and so on, as well as weather details like temperature, wind speed, and that sort of stuff. So basically what we have to do is parse this dictionary so that it would extract only those details that we are interested, and so that we could use those details to create a response message that our bot will send back to us. So now I'm going to parse the bits that I'm interested in. So for example, country, and I will take location and country. I would also like to get a city name. So I will take current, location, and it is called name. Now I will take a condition. So is it sunny, is it rainy, and so on. So it goes current, and should be condition and text. I will also retrieve temperature. So I will go with current again, and temp underscore C. And then I will take humidity as well. So it'll be current, and humidity. And the last one, let's say, will be wind speed. So wind mph, and I will take current, wind mph. So in all these variables, I will save the details from the response dictionary, so that I would use those details in creating a response message that will be sent out back to me by a chatbot. And now I can create that response message, and I will call this message response. And it will be a simple text message that I will want my chatbot to send with all these weather details that I extracted from a response dictionary. So let's say when I will ask for weather details, my chatbot will respond with something like this. It is currently whatever the condition is in whatever the location is at the moment. And I will also provide some weather details. So I will say the temperature is whatever the temperature will be, degrees, the humidity, is whatever percent, and the wind speed is whatever the wind speed is, mph. And at the end I will just simply pass all these variables, which will be placed in those empty brackets. So I have condition, then I will put city in, temperature Celsius, humidity, and wind speed. That's it. Yeah. So this is going to be my response message that a chatbot will send out back to me once I will ask for weather conditions. And now the last thing that I'm going to do is to actually tell my chatbot that this message has to be sent out. So there is a dispatcher from Rasa core, which has a method called utter message, which is basically will send out the message, and I will provide what message I will send, which is response. And last but not least, I will simply return the current slot value, and I will do slot set, and I have a slot called location and the variable which is lock. And that's it. So this is the custom action. So basically when action weather will be triggered, we will make an API call, get the details, and send those details back to a user. And now I will save this custom action. And the last thing that we have to do is to actually include this action in our domain. So after saving, I'm going to get back to weather domain for a second, and at the very end, I will add this action to actions list. So in actions file, we have a class called action weather. So our chatbot will know that there is this action as well, that it should be ready to execute when needed. Great, so now I'm going to save this file again, and let's move on to the next stage. And the next stage is data. A dialogue management model is trained on actual conversations that users have with the bot. The only thing that has to be done with those conversations is that they have to be converted into a story format. A story is an actual conversation between a user and a chatbot, where user inputs are converted into corresponding intents and entities, while the responses of a chatbot are expressed as actions, which a bot would execute at that specific stage. This is one of the examples of how a real conversation would be written as a story. Now, $1 million question is, how to get this data in the first place? My first suggestion is to put yourself into a bot's shoes and think of what conversations users would have with you. Or even better, ask your friends to help you out by asking questions, and simply write down those conversations and use them as training examples. Another way of getting started is using a very cool Rasa core feature called online training, which will not only help you out with generating story data, but it will also train a dialogue management model in real time, which looks really awesome. First, I'm going to show you the latter. To do so, we will need a tiny sample of stateless stories, so let's go and generate some. Okay, so for stories data, we are going to create a completely new file, and that's why I'm back to my terminal, and just like we did with NLU model, we will do this in data folder. So now I'm going to data folder, and here I will create a new file, which I will call stories. And this file will have a markdown extension, so that's why it will be stories.md. And I should have my file created now, and in folder data I have stories.md. So I'm going to open it up, and in this file I'm going to start with just a very few stateless stories. And stateless stories are going to be those conversations, but they will only consist with one user input and one chatbot response. So I'm going to write the first story. So let's say it will be a conversation which will start with greet, and the response of a chatbot will be utterance greet. So this is one stateless story now. I will add another one. So it will be story number 2. And now it will be a conversation which will start with goodbye. And the response of a chatbot will be utterance goodbye. The third one, story number 3, it will start with inform intent. So it will be me asking about weather, and the chatbot's response will be utterance ask location. And the last one that I'm going to include, story number 4, will be also starting with inform intent, but this time the response will be action weather. Okay, so now I'm going to save this file, and it's going to be enough to get started online training session. To start an online training session, I'm going to use 2 Python files from my GitHub, and they are called traininit.py and trainonline.py. So if you are following along, go grab them, and I will walk you through the code in those 2 files. So the first file that I'm going to use for online training session is called traininit.py from my GitHub, and I'm going to walk you through what's going on here. So this script is going to train a very simple dialog management model, and I have some import statements here. So agent is going to be used to train the model, while Keras policy and memoization policy are the models themselves that are going to be used to train the model. And then in the main of this file I have a training data file. So we basically tell what data file we are going to use for dialog management model, and I'm going to use stories MD, the one we created previously. And in model path, I'm going to specify where I would like to save a model after it's trained, and I will save it in models folder and dialog subfolder. So then I have an agent which is going to be initialized, and I'm using a class agent from Rasa core to do this. And I have to provide 2 parameters. So the first one is a domain, and I'm using the weather domain which we created previously. And another parameter is policies, the models that are going to be used to train the model. If you want to, you can create your own policies. For example, Keras policy is an LSTM, so if you want to, you can tune the parameters, you can add or remove layers. But to keep this tutorial simple, I'm going to use policies already pre-made in Rasa core, and they are actually doing really great job, so it's going to be enough for this little project. So then I just train the model, and I have a bunch of parameters provided. So the first one is training data file, so our stories data. Second one is augmentation factor. So Rasa core also helps out with training data a little bit, because it creates some fake stories from the ones that we have in our stories data file, and here we can specify how many of those stories we want to be created. I specified 50 here. Next parameter is max history, and it stands for the number of states that the model should remember, and as long as our data file is small, I'm going to use only 2. Then there is epochs, which stands for the number of forward and backward passes of training data in the training process. and the batch size, which corresponds to the amount of training samples which should be used in each pass of training. And since our data file is very small, I'm going to use only 10. And the last parameter is validation split, which stands for the percentage of data that should be used to validate the model. And I have this set to 0.2. And the last step is to save the model. So with agent.persist, I am saving the model in specified location. So what I'm going to do now is I'm going to run the script so that the model would be trained. So now I'm in my console and I'm going to run the script with Python train init.py, and it should run really fast because our training data sample is very small. And the training is done, and the model is saved in models dialog directory. So to be sure that I actually have this model trained, I'm going to check it out. So in my main directory, I have models folder, and there is a subfolder dialog, and all these files will create a dialog management model, which we are going to try out in a few seconds when we will launch online training session. And to do so, we will need another file. So this next file is called trainonline.py. So again, I'm going to walk you through what's going on here. So I have a few additional libraries imported, console, input channel, and Rasa NLU interpreter. So these two are needed because online training session is an actual conversation with a chatbot, and we will be sending messages, and to be able to send messages to the bot, we will need input channel, which will be console for now, and we will also need some parser to parse incoming messages and extract features from those messages, and we have our NLU model for that. So this is what we are going to be using, and load this with Rasa NLU interpreter. So there is a function called run weather online, and what it's going to do, it will fit a dialog management model, and we'll launch it in online training session so that we could improve this model even more. And there are a few parameters. So input channel, which is going to be our console. We also have an interpreter, which will be our NLU model. Then domain file, so weather domain, and training data file, which is our stories. And at the end, we simply load our model, which was saved in models NLU default weather NLU, and run weather online function and launch the model in online training session. So I will save this and go back to my terminal and run the script. Okay, so I will type Python train online.py, and after it will fit a dialog management model, online training session should start. So this is how the beginning of online training session looks like. I can see that the bot is waiting for my messages. So what is interesting about online training sessions is that they are actual conversations with a chatbot. The only thing is that before replying with some text messages or actions, a chatbot will tell me what it thinks it should do at that specific state of the conversation and will ask for my feedback. And if I will see that a chatbot is about to make some mistakes, I will be able to tell this to the chatbot, and it will learn from that feedback and it will improve over time. So I'm going to start the conversation with a simple hello message. And now I can see what a chatbot thinks. So I said hello, and I can see that chatbot did understand that I am greeting because NLU model correctly classified this input message as greet. And it didn't find any entities, and it didn't populate any slots, which is correct because we don't have any in this hello message. And now chatbot tells me that it wants to execute utterance greet. And it is correct because that means that a chatbot wants to respond with a message, hello, how can I help? And it asks me if it's correct. And yes, it is correct. And I have to select the corresponding option from this menu. And I will select the first one because it is all correct. And now chatbot responded with, hello, how can I help? And now bot wants to execute action listen, and action listen is inbuilt Rasa core action, which means that a chatbot is waiting for a next input from a user. And is this correct? Yes, indeed, it is correct because I will definitely want to ask some questions. So the next user input, and now I'm going to ask about the weather. So I will ask the tricky question and I will just simply ask, what's the weather? Okay, so chatbot did understand that I'm asking something about the weather because intent is inform, and it didn't find any entities, no slots are populated, which is correct because there aren't any in this message. And now I can see that my bot wants to execute action ask location. And that is actually correct because I didn't tell what location I'm interested in, and this is the action that a chatbot should have asked before it goes and retrieves weather data. So yes, it is correct. And a chatbot responded with in what location, and now it is going to listen to my input where I should tell what location I'm asking about. And here I will have to provide the location, so I will probably say in Italy. Okay, so a chatbot did understand that I provided some additional details regarding weather-related question because it did classify this in Italy sentence as inform, intention, which is correct, and it did find an entity, Italy. And as we can see, it is set as a slot, which is all correct so far. And now I can see that my bot wants to execute utterance ask location again. Well, which doesn't really make sense because we already told what location we are interested in. So basically, a chatbot is about to make a mistake. And now I can provide some feedback and tell what a chatbot should do instead. So as long as intent was classified correctly but the action is incorrect, the option that I'm going to select now is going to be number 2, that no intent is right but the action is wrong. So instead, a chatbot should have simply executed action weather because we provided the location name and a chatbot is good to go and make an API call and retrieve weather details, and that's why I'm going to select option number 5. And now a chatbot finally made an API call and retrieved some weather details. So it says that it is currently patchy rain possible in Rome at the moment. The temperature is 7.3 degrees, the humidity is 67%, and the wind speed is 4.5 miles per hour. Awesome. And now my chatbot wants to listen to the next message, and yeah, that is correct. And now I'm going to simply say goodbye, and we'll end this online session. So my bot did understand that I'm saying goodbye because the intent is goodbye, and slot is still Italy because it is being kept now throughout the conversation, unless I would specify another location and then it would be reset. And my bot wants to respond with goodbye, and it is correct. So I'm going to say yes, that is correct, and my chatbot responded with bye-bye. Okay, and now chatbot wants to listen, but I'm going to end this online training session now. And all these changes that we provided to the chatbot are going to be saved automatically, and the model is being improved as we did this online training session. And one additional thing that we can do is to get this conversation that we had as a training data sample. And I'm going to do this by choosing the very last option here, export current conversations as stories and quit. So 0, and I have to provide the name of the file where I would like to save generated data. So I will just specify stories.md. And it is saved in weatherbot directory. So let's take a look how it looks like. So weatherbot, and I have stories.md file here. And this is a generated story, so basically the entire conversation that we had with our chatbot. And it is already in Rasa core stories format, so we can simply take this conversation and add this to our training samples and use it for our model. And it is exactly what I'm going to do. So since my current training data consists of only few stateless stories, I will take this example and copy this, and will paste in my original stories markdown file, which we created previously, and I will paste this story right here. Now, of course, one story is not going to be enough to train a good model. And what I'm going to do is I'm going to use some examples which I have pre-made already, and they are in stories MD file on my GitHub. So I'm going to add those examples to this file, and then I will retrain the model, which is going to be the final dialogue management model, which we will use in the final version of our chatbot. So this is how my stories MD file looks like after I added those few additional examples from my GitHub file. So I still don't have too much data here. I only added few generated stories and a few stories which I wrote myself. But again, since our chatbot is going to be quite simple, it is going to be hopefully enough. But if you want to, of course, you can expand this training data sample, and the more stories you have and the more diverse those stories are, the better the bot will be and the more scalable a chatbot will be, and it will be able to handle a lot more interesting and different conversations. So now I'm going to take this new bigger training data sample, and I will use it to train the final version of dialogue management model. And once we do this, we will test our chatbot and we will integrate it into Slack. So we are almost done, and let's go and create the final dialogue management model. So I'm going to start with creating a new script. So I'll create a new file called dialogue management model.py, and this script will be used to not only train our final dialogue management model, but to also load it in a console and test it out. So okay, I have my file. I'm going to open it, and I will delete this dialogue message from here. Okay, so the first thing that I'm going to do is to import the libraries, but since they are going to be the same as we used in the trainonline.py file, I'm just going to copy them from this file. Okay. So the first thing that I'm going to do, I will make sure that I have a logger, which will keep track of things that are happening in case I will need to debug something. Okay, and here I will implement two functions. So the first one will be for training of the final model. So I will initialize a function called train dialogue. and I will provide 3 parameters. So the first one will be my domain file, and we have a domain which is called weather domain.iml. Second parameter is a model path, so where we will save it. So I will use the same directory, which will be models dialog. And third parameter is training data. So it is in data folder, so our new updated file, and it is called stories.md. Okay, so the first thing, just like in online model, we will initialize an agent. So agent, and here I will use Rasa core class agent, and I will provide my domain, which is domain file, and policies. So I will use the same memorization policy and the Keras policy. And now I can train the model. So agent.train, and I will provide the parameters. So training data file and max history. Since I have a little bit more data, I will set this parameter to 3. And then epochs. This time I will set this to 300. And batch size, again, since I have more data, I will set this to a higher number, 50. Then validation split, which I will keep the same, 0.2. And augmentation factor, which I will keep 50, just like it was before. Okay, and the last thing that we have to do is to save the model. So let's call agent.persist, and let's save it in our model path directory. And that's it. So I'm going to return the agent. So this function will train the final dialog management model. And what I'm going to do now is to create another function. And this function will be used to load the agent and to test it out in our console. So I will initialize function run weather bot. And since we are going to use console as our input channel, I'm going to check if this server is constantly listening to incoming messages, if it's ready to get messages. So if serve forever is true. Okay, so the first thing that I'm going to do is to load our Rasa NLU model, because it is going to be used to parse messages. So interpreter is going to be with Rasa NLU interpreter. I will load Rasa NLU model, which, if you remember, is in models, NLU, default, and called weather NLU. And then we will load an agent. And I will use agent class and its method load. And I have to provide the path of where our model is, and it's going to be saved in models dialog directory. So I will provide this models dialog. and the interpreter, which is going to be our Rasa NLU interpreter. Okay, so when I have my model and agent loaded, I can start listening to incoming messages. So let's check if the server is ready. And if it is, let's initialize console channel with agent handle channel. And our input channel is going to be console, and there is console input channel already created in Rasa core, and that's what I'm going to use. Console input channel. And that's it. Now I'm going to return agent and create the main of the script. So at first I'm going to train the dialog management model. So I will run train dialog, and once it's done, I will want my chatbot to be loaded so that I would be able to test it out. So I will run weather bot. Cool, so I'm going to save this file. And I will run it in my console. So Python dialog management model.py. Okay, so in this will train the final version of dialog management model. And now it is loaded, and I can test it with messages that I want to test it on. And in contrast to online training, it will give me responses immediately. So I will start with hello, and my chatbot responded with hello, how can I help? And now I will ask, tell me the weather, and a bot asked in what location. Let's say Sweden. And we have a response. So the chatbot says that currently it is light snow in Stockholm at the moment. The temperature is -4 degrees, the humidity is 93%, and the wind speed is 11.9 miles per hour. Ooh, it's quite cold in Stockholm. Okay, so I'm going to finish this conversation by saying goodbye, and my chatbot responded with talk to you later. Great, so that's it. We have a chatbot which is working, and well, actually it works quite fine. It didn't make any mistakes, and we can see that more data actually makes a lot of difference. Now if you want to, you can stop right here, or you can use a front end of your choice. But what I'm going to do is I'm going to show you how you can integrate this chatbot into Slack. So let's go. I will start Slack integration by creating a Slack app. So the chatbot that we created is going to be integrated into a Slack app, and it is needed because only Slack apps can send interactive messages to Slack. So by interactive messages, I mean messages with buttons, messages with pictures, and so on. So I find it always best to start with a Slack app and integrate your bot inside that app. So api.slack.com is a place on Slack where you can create apps. So if you have a Slack account, a personal one, or your team's one, you can log in and go to this page. So I have already logged into my own Slack account, and going to click Start Building. Okay, we can create a Slack app now. And the first thing that we have to do is to create a name for our app. And well, it is a very important step because this is where we start creating a character for our chatbot. So let's say I will call mine Frank. and I have to choose development Slack workplace, so what team or what account I want this app to be installed on. So I will choose my own bot workplace and I will click create app. Okay, so this is our apps page. So I can see Frank is there. And in this basic information page, I can configure a lot of bits about my Slack app, add a lot of functions, and subscribe to different events. So the first thing that I'm going to do is I'm going to integrate a bot user to this app. So I will click on Bots tab. And here I can create a bot user, which is going to be integrated into a Slack app, which will make app conversational. So I will click add a bot user, and I can write a new name for my bot user, but I'm going to leave it the same as I have for my Slack app. And at the bottom of the page, I have an option to always show my bot online. So when we will create this app, it is going to be created as a user on Slack. So we can show this user constantly online or not if you want to. So I will probably choose this option on. And I will click add bot user. Okay, that was successful. And to be sure I save all the changes, I will click save changes button. Great, so this should integrate a bot user into my app. I will go to basic information again, and under add features and functionality tab, I can see that, yeah, I have a bot and permissions tabs active, which means that we have a bot integrated into this app. Great. Now I'm going to go down to the bottom of the page. And this is where we can add a little bit more information about who Frank is. Okay, so I have my app's name, which is Frank. And now I can add a picture of who Frank is. Now, there is this thing that I don't really like, humanized bots. I don't know why. But what I really do like is bots which are dogs, because it makes perfect sense. Bots, just like dogs, sometimes do some weird stuff, but they are always happy to hear from you. They are always there to help you. And me, as a dog lover, I have an excuse to create bots as dogs. So I'm going to do the same thing with Frank. And let's add a picture to Frank. And this is Frank. So say hello to Frank. Okay, and I can also add a description to describe who Frank is. So I will say that it is Frank, the weather dog. Okay, and I can choose a background color, so I will keep it dark. And I will save the changes. Great, so Frank is ready and is waiting for incoming messages. And the last bit that I'm going to do now is I'm going to install this app into my workplace. And I can do this here, install your app to your workplace. And this will direct me into this authorization page where I have to tell if I really want to integrate Frank into my bot workplace and if I really want to add a bot user with username Frank. And yes, I definitely want to do this, and I will click authorize. And that's it. So we have our app ready and a bot integrated. And what I'm going to do now is I'm going to leave this page for now. And I'm going to write a Python script which will integrate our chatbot, which we created locally, to this Slack app so that we could start communicating with our chatbot on Slack. So let's go and do this. I'm going to start by creating a Slack connector for my Rasa chatbot. So for this, I will create a completely new Python script, and I will call this script Rasa Slack connector.py. Okay, and it should be ready, so I'm going to open it up. Okay. At the beginning, as usual, I'm going to import some functions from future modules. So since they're going to be the same as I used in previous scripts, I'm going to copy them, for example, from dialog manager and model.py file. Okay, so I'll take these and just copy them. Okay, and then some additional libraries. So from built-ins, I will import str, and from Flask, I will import blueprint, request, and JSONify. So it is a hint that I'm going to use Flask as a web server, and some Rasa core stuff. Okay, so from Rasa core channels dot channel, I will import user message and output channel. And from Rasa core channels rest, import HTTP input component. Great. Okay, so I'm going to start with Logger as usual, so that it would be easier to debug the code. Okay, so our connector is going to consist of two main parts, input channel and output channel. Input channel will take messages from Slack and will pass them to Rasa core and Rasa NLU, while output channel will take messages returned by Rasa core and will send them back to Slack. So for this, I will create two classes, and the first one will be our output channel, and I will call this class SlackBot, and I will pass output channel as a parameter here. And the second class is going to be our input channel, so I will call it Slack input, and I will pass HTTP input component. Okay, so I will start with the input channel, and we will create output channel right after. Okay, so I will start with init function, and here I will pass some tokens which are going to be used to authenticate our chatbot and our app. I'm going to show you where to find them a bit later, but now let's just initialize them. So I will provide Slack dev token, Slack verification token, Slack client, and I will have debug mode for debugging. Okay, so now let's initialize those parameters. So I will start with Slack dev token, and then self debug mode, then Slack client, and the last one is Slack verification token. Okay, great. Okay, now let's create the main part of our Slack input channel, which is going to be a server. And since my app will communicate with my chatbot using HTTP requests, I will use Flask. And to start, I'm going to create a function blueprint for my server, and I will pass on a new message parameter for this function. And since I'm using Flask, I will import a few additional things. So from Flask, I will import Flask, request, and response. And now I'm going to initialize a Flask blueprint so that our server would be ready to use, and I will call it Slack webhook. Okay, so blueprint, and I will pass the name of my blueprint, which is going to be Slack webhook. Great. And now I'm going to create the routes for URLs, which are going to trigger specific functions. And the messages that we are going to be sending from Slack, they are going to be sent using post requests, but just in case we would get a GET request, let's tell our script how it should respond. So I will create a route, Slack webhook.route. Now I'm going to provide URL prefix and methods get for a GET request. So I will create a very simple function called health, which is not going to do much. It will simply return a message with a status okay. So basically that everything's fine, but it's not going to do anything else. Okay, so status okay. Okay. And now I'm going to create another route for post requests, and I will create a URL prefix for this, which is going to be Slack events, and methods will be post. Okay, now I'm going to create a function called event. Great. As I said, we are going to get messages from Slack using those post requests, and the first thing that is going to happen when we will connect our chatbot to Slack is that our app will send a request, a challenge request to our script, and it will expect a response with the same challenge message. So the first thing that we have to do is to implement a check for this URL verification. So I'm going to do this by if request.json get. So basically, if the message that we are getting, the type of this message is URL verification, we have to respond. So I'm going to return the same challenge message from this message that was sent to me. So I will take challenge out from that message, and I will send response 200. Okay, and another type of messages that we are going to get are going to be an actual user messages. So of course we most definitely have to check who is sending those messages, and only authorized app and our authorized bot should be able to send messages to this locally running chatbot. So at first let's check if a token of that message is a verified token, which is going to be a Slack client, and I'm going to also check if the type of the message that I'm going to get is event callback, which stands for an actual message being sent from an app on Slack. And if it is, then we can parse incoming message. So I'm going to initialize data variable, and I will take a payload from this incoming message with request.json, and I'm going to be interested in messaging events because this payload will have quite a lot of details, and I will take out things that are related to incoming message only. So I will take event out. Okay, and in those incoming messages there are going to be a few details that I'm going to be particularly interested in, which are channel and user ID, who is sending a message, as well as the message itself. So I will need those messages to be able to send messages back to the same channel and the same user. So I'm going to parse channel first. And then I will take a user so that I would know who to send a message back to. So I will retrieve a user, which will give me user ID. And of course, I will want to get a message itself. So I will retrieve text. And the last bit is going to be bot ID. So I will retrieve from messaging events, I will get bot ID. Okay, so this bot ID is going to be important when we will check who is sending a message. So when a user is going to be sent a message from Slack, those messages won't have a bot ID attached. But when our bot will be sending responses back, those messages will have a bot ID. And what is going to happen is, if we won't check who is sending a message, our chatbot may start responding to its own messages, and we can avoid this by checking who is sending a message. And this bot ID is the best piece of information that would allow us to do so. So I will implement if statement. If bot, which is bot ID, if it is none, then it means that a message was sent by a user, and we can pass this message to Rasa core so that predictions would be made. And I will call on new message and user message, and I will provide two parameters: text, which is going to be our message, and the output channel, which we called Slack bot. And I will provide two parameters. So the first one is going to be Slack verification token, because we will have to do some authentication over there as well. And I will pass channel, so that my output channel would know automatically what channel this message should be sent to. Okay, and I'm going to finish this event function by returning a response. And I will complete blueprint function by returning a Slack webhook. Okay, so this is our Slack input class finished. It will take messages from Slack and it will provide them to Rasa core when it is needed. And now let's create our output channel, which will send messages back to Slack. So I will start with init function. And here I will have two parameters, which is going to be Slack verification token and channel. Okay, let's initialize them. So Slack verification token, and channel. And now I'm going to create the main function which is going to do all the work. So I will call the function send text message, and I will have few parameters here. So it's going to be self, recipient ID, and message. And this message is going to be sent by Rasa core back to us. So I'm going to send messages to Slack using a helper library which is called Slack client. So I will import from Slack client, I'll import Slack client, and I'm going to simply save that incoming text message which is going to be sent from Rasa core to us, and a recipient ID. And now what I have to do is I have to authenticate my user. So basically that this script responding and sending message back to Slack is authenticated, which I will do by calling Slack client class and by providing a Slack verification token. Great. And now the last thing that I have to do is I have to send this message out to Slack, and I will do this by making an API call from Slack client library, and I have to provide URL which is going to be chat post message, as well as what channel this message should be sent to, which we will have passed to us from input channel, and then what message should be sent out, and this message will be from Rasa core, and should this message be sent as user. I will set this to true. And that's it. So this is completed Slack output channel. Well, of course, it's going to send only simple messages, but that's all we need for our simple chatbot. So we have all the pieces together now. We have a connector, we have a Slack app, we have Rasa core and Rasa NLU models ready. And what we have to do now is just to do the plumbing, so to put everything together and run our chatbot on Slack. So let's go and create one last script which is going to do so. And I will call this final Python script run app .py. Okay, so I will start by importing libraries which I will need here. So from channels I will import HTTP input channel, as well as from Rasa core agent I will import agent class. I will also need interpreter, and I will use from Rasa NLU interpreter. And let's import our input channel. So from Rasa Slack connector I will import Slack input. Great. So here I'm going to load both models, Rasa NLU and Rasa dialog management model. So I will call NLU interpreter, and by using Rasa NLU interpreter class, I will load my model. So I have to provide a path of where our model is. If you remember, it is in models, NLU, default, and called weather NLU. Okay, and now let's load an agent. So I will call agent variable, and using method load from agent class, I will load my model. So the model is in models dialog directory, and interpreter that we're going to use is going to be our NLU model. So I'll provide NLU interpreter. Okay, and now I'm going to initialize input channel, which is going to be our Slack input class. Okay. And I'm going to finish the script by telling my agent that it should initialize input channels and start listening to incoming messages. So I'll call handle channel method, and I will provide HTTP input channel as parameter. And here I have to tell what port my server should listen to. This is your choice. Basically, I'm going to choose port 5004. Also, another parameter is a URL prefix that should be passed to a server to listen to, and also what is input channel, which is going to be our input channel. And now we have to provide some parameters to our Slack input class. If you remember, we had quite a few tokens specified here. So now we have to provide them, and all of them can be found in Slack customization page. So I'm going to show you where to find them. So I'm going to my Slack apps configuration page, and the first two parameters we are looking for are our apps verification token and our bots verification token, and both of these tokens can be found in permissions tab. And so these two tokens are the ones we need. The first one is for our app, the second one is for our bot. So I'm going to copy the first one, and I will provide to Slack input. And now I'm going to go back and copy our bot's verification token. So you can see the one for app starts with XOXB, while for a bot is XOXB. And the third parameter is our Slack verification token, which you can find in basic information under app credentials part, and there is verification token. So I'm going to copy this and provide, and this token is used for interactive events, and I'm going to also provide debug mode true. And this is it. That's all we need. Everything is loaded, our models are loaded, we have our input channel, and our chatbot should be ready to start listening to messages. So I'm going to run a script, run app, which will launch everything on our bot side, and we'll start listening to incoming messages. Okay, so these are just the warnings related to TensorFlow. It's not related to script. So I didn't get any errors, which means that everything should be fine. And now what we have to do is we have to create a connection in between our locally running chatbot and Slack. And for this I'm going to use ngrok, and I will have to launch ngrok with the same port as I used for my Slack app, which was 5004. So I'm going to launch ngrok session with 5004 port. And here what I'm interested in is a forwarding URL, which I will have to pass to Slack so that it would know what URL is going to be used for communication in between my local app and Slack. So I'm going to copy this URL, and I will pass this to Slack. So I'm going to go back to my bot's configuration page, and I will provide this URL into event subscriptions tab right here. So in this page I can enable events, and events are all messages and any other event that can happen and that can my chatbot can be involved in. So I have to provide a URL which is going to be used for communication in between my chatbot and a user on Slack, and it has to be verified. And don't get scared about this error. If you remember, in our Slack input we had a URL prefix Slack events, and we have to attach this Slack events to our ngrok URL. Okay, and now you can see the URL was verified, which means that communication was established. And I can see that ngrok also says that everything's fine, and this error is from the previous attempt to verify my URL. Okay, and the last thing that we have to do is we have to subscribe to some events for our chatbot so that it would be responding to things that are happening. So the first thing that I'm going to subscribe is going to be app mentions. So when someone will send a message and will mention my bot, Frank, my chatbot will respond. And another thing that I'm going to subscribe is going to be direct messages, which are called message im. So this will allow me to send direct messages to my chatbot, and the chatbot will respond. Okay, I think this is it. I'm going to save changes, and that's all. It's done. Our chatbot should be responding by now, so I'm going to test it out. So this is Frank waiting for my messages. So let's have a chat. Okay, I'm going to say, hello, Frank. And yay, Frank responded, and he says, hello, how can I help? Okay, I will ask, what's the weather? In what location? Okay, so I will say in Vilnius. And we have weather details. Great. So it is currently light snow in Vilnius at the moment. The temperature is -8 degrees, humidity 79%, and the wind speed is 11.9 miles per hour. Awesome. Okay, I'm going to respond with great, goodbye, and Frank said bye-bye. Cool, so this is it. Our chatbot is running on Slack, and it is responding to direct messages. If you want to, you can send messages from some kind of specific channel that you want your chatbot to live in. Just simply use mentions. So for example, @Frank, and your chatbot should respond. And this is the end of my tutorial. So I really hope you learned something. I hope you found it interesting and useful. I'm going to add a bunch of links to Rasa documentation, as well as links to all the files that are used in this tutorial. I will also include a worked out example, so full code of this tutorial. So if you want to, you can go grab it and use it and tweak the code. And yeah, definitely go check out Rasa HQ Gitter, because over there they have a really active community, starting with developers who are using Rasa Stack, ending with developers of Rasa Stack themselves. If you have any questions, simply send them over to me. I would be happy to help you. Definitely show off the chatbots you're going to build, and I'm going to say goodbye now, and I'll talk to you the next time.